Welcome to Algebra 1. Today's lesson is 5.6, graphing inequalities in two variables. Let's go ahead and get started. Previous objective was to graph linear equations. So we've done graphing already. Today we're going to incorporate the inequality symbol. Previous objective was to graph linear inequalities on the coordinate plane, as well as solve inequalities by graphing. So two objectives for today. The one vocabulary word that you have is a boundary, and a boundary with inequalities on a graph is that divided line that divides your coordinate plane into two halves. A couple other key concepts that I want you to write, they're very important and very helpful when we are graphing, is that when it's just a less than or greater than, it's a dashed or dotted line, versus with the equal sign, it makes it a solid line when you're graphing that line. And then when we shade, if it's less than or equal to, it's shaded below the line, and greater than or equal to is shaded above the line. So let's go ahead and get started. It says to graph 2y minus 4x is greater than 6. Well, if you recall from chapter 2, 3, and even 4, that when we graph, we have to put it in the form y equals mx plus b. We figure out what our y-intercept is, we figure out what our slope is, and we graph the line. So the same rules are going to apply. So we're going to solve for y in terms of x, basically y equals mx plus b form. Here was my original inequality. We're going to add 4 to both sides, and then our last step is to divide each side by 2. So my inequality in terms of slope-intercept form is y is greater than 2x plus 3. Step number 2 is to graph y equals 2x plus 3. Since y is greater than 2x plus 3 does not include that line, that boundary, this is where those key concepts come into play, is because it's just a less than or greater than and not greater than or equal to. It's the difference between a dotted line and a solid line. So this line is dotted because it's just greater than. So we went up 3, made a dot, and our slope is up 2 over 1, down 2 over 1. Step number 3 is to shade your solutions. So our inequality is greater than, so we have to shade above the dashed line. And that means that any point above that shaded would make this inequality a true statement. So any of your shaded answers, any point in the shaded region would make your inequality true. So let's go ahead and try a few on our own. If you want to pause the video, you are more than welcome to, and see if you can get the same answer as I do. So step number 1 is y equals mx plus b. So I'm going to add 3x to both sides. And I get y is greater than 3x plus 1. So this is kind of like step number 1, is putting it into slope-intercept form. Step number 2 is to graph it. So I'm going to go up to 1, and I'm going to make a dot. That's my y-intercept. And my slope is up 1, 2, 3 over 1, and down 1, 2, 3 over 1. Now, because it's just greater than, just like in the last example, it's not going to be a solid line. It's going to be a dashed line. Step number 3 is to now shade it. So because it's greater than, it's going to be shaded above the line. So anything above this dotted line would make this inequality true. So with that being said, we are to the multiple choice question on the Google page. So y minus 3x is less than 2. You're going to go through the steps. Put it into y equals mx plus b form. Decide if it's a dotted line or a solid line, and then decide should it be shaded above or below the dotted line, also known as the boundary or the solid line. All right, example number 2 is basically the exact same thing, but they broke it apart, and now we have inequalities that are less than or equal to or greater than or equal to. So step number 1 is to subtract the x from both sides. I get 4y is greater than or equal to negative, I'm going to put the 1 in front, plus 2. And now I'm going to divide everything by 4. So step number 1, my equation is y is greater than or equal to negative 1/4 x plus 1/2. So step number 2, now I'm going to graph it. And I'm going to go up to a half. And then my slope, it's a negative slope, so I'm going to go down 1 and over 1, 2, 3, 4. And then I'm going to go up 1 and over 1, 2, 3, 4. Because it is greater than or equal to, this becomes a solid line through these points. And then my third and final step is to shade. And because it's greater than, I am also going to shade everything above the line. All right, so now let's try another example. I'm going to subtract the x from both sides, very similar. I have 2y is greater than or equal to negative 1x plus 6. And my last step is to divide everything by 2. So step number 1, my equation is y is greater than or equal to negative 1/2 x plus 3. Step number 2 is to graph it. And I'm going to go up 1, 2, 3, and it's a negative slope. So I'm going to go down 1 and over 2, and up 1 and over 2. And it is an equal sign, so it should be a solid line. And again, because it's greater than, my last step is to shade. And again, I'm going to shade everything above that line. All right, we're going to do one more example here. I am going to subtract, I'm going to add 4x to both sides. And I get 2y is greater than or equal to 4x plus 6. And now divide everything by 2. So step number 1, my equation is y is greater than or equal to 2x plus 3. Step number 2 is to graph it. So I'm going to go up to 1, 2, 3, make my dot. My slope is up 2 over 1 and down 2 over 1. It is an equal sign, so I'm going to make it a solid line. Step number 2, we graphed it, and step number 3, we are going to shade it. So it is greater than, I'm going to shade everything above that line. That's it for the lesson. It's just a lot of graphing. I will provide you with graph paper tomorrow so you can solve the equations and then graph on the graph paper provided. Because your answers are graphs, I am not going to have an open-ended question for this lesson. So what I want you to do in the open-ended part of the Google form is to tell me what your favorite thing that you have planned for over break is going to be. That is it for lesson 5.6.